Hi everyone, welcome back to my YouTube channel. This is Dr. Ruby and today's class is on another important theory in cognitive development, which is Bruner's theory of cognitive development. In our previous class, we have explored Piaget's theory, discussing how children develop their thinking and reasoning abilities across different stages. If you have missed that video, make sure to check it out in the playlist called Educational Psychology. I'll also provide the link in the description below. Today we will build on that foundation as we explore Jerome Bruner's contribution to understanding how we learn. While we have covered the concept of cognitive development in our previous lesson on Piaget, a quick revision will help us refresh our understanding. We will understand the core concepts of Bruner's theory, which are scaffolding and spiral curriculum. These concepts are pivotal in understanding his theory, very important for educators to understand. We will discuss who Bruner was and why his theory was so influential in the field of education. We will understand his theory and the stages he proposed, which are enactive, iconic, and symbolic. We will finally see how these concepts are applied in real-world educational settings and how they can transform the learning experiences. Now grab your notes and get ready. Or as I explain, you may pause the video in between and take screenshots of it. Also, if you are yet to subscribe to this channel, please subscribe now and press the bell icon so that you get notified every time I upload a new video. Now let's have a revision on the concept of cognitive development. Cognitive development refers to the process through which individuals acquire, organize, and utilize knowledge and cognitive skills throughout their lifespan. It involves how thinking, reasoning, problem solving, and understanding evolves from infancy through adulthood. Now, why is this important? For educators, understanding cognitive development means being able to tailor teaching strategies to fit the developmental needs of learners. For example, a teacher who understands that a young child is in the early stage of cognitive development may use more hands-on activities and visual aids rather than abstract reasoning, which is more suitable for older children. Today, as we discuss Bruner's theory, we will see how these stages of cognitive growth inform our teaching methods and curriculum design. Now, let us understand the core concepts of this theory, which are scaffolding and spiral curriculum. Scaffolding is the idea of providing temporary support to learners to help them achieve a higher level of understanding than they would on their own. For example, think of how a teacher might assist a child in solving a math problem by first demonstrating the steps, then guiding the child through similar problems, and finally, allowing them to solve problems independently. As the learner gains confidence, the support is gradually removed. This concept is especially used in differentiated instruction, where each student may need different level of support based on their current skills. Now, spiral curriculum. Bruner proposed that education should revisit basic ideas repeatedly, building upon them until the student has grasped the full concept. This means key concepts are introduced early and revisited over time with increasing complexity. For example, in science education, students might first learn about the basic properties of matter in elementary school. Then in middle school, they explore these properties in more detail by discussing atoms and molecules. And by high school, they dive into complex chemical reaction and molecular structures. This spiral approach reinforces learning and deepens understanding. This concept shows us that learning is not just a one-time event. It is an ongoing process that builds upon itself. Now let us learn about the man behind this theory, Jerome Bruner. Jerome Bruner was a pioneering American psychologist who revolutionized our understanding of education and learning processes. He was especially interested in how individuals construct their knowledge and the pivotal role of social interaction in cognitive development. Unlike some of his contemporaries, Bruner believed that the environment and social context significantly influence cognitive growth. Bruner's research emphasized active learning. That is, learning that involves exploration, problem solving, and discovery. For example, instead of merely memorizing facts, students engage in activities that require them to apply concepts, analyze situations, and create new ideas. He also highlighted the cultural context of learning, emphasizing that education should reflect the cultural and social norms of the learners. His work has deeply influenced modern educational practices, advocating for approaches that emphasize understanding over rote memorization. Now, coming to Bruner's theory. Bruner's theory centers around the idea that learning is an active process where learners build new ideas based on their current or past knowledge. According to him, cognitive development is not a passive absorption of knowledge, but an active process of problem solving and discovery. At its core, Bruner's theory aligns with constructivist principles. This means learners are seen as constructors of their knowledge. For example, in a classroom where constructivist principles are applied, students might work in groups to research a topic, discuss their findings, and they present their understanding to the class rather than just listening to a lecture. Bruner also emphasized the importance of discovery learning, where students learn by exploring and discovering concepts for themselves. For example, instead of directly teaching the formula for the area of a triangle, a teacher might guide students to discover it by cutting out shapes and experimenting to see what fits into a rectangle. Bruner outlined 3 modes of representation through which knowledge is processed, stored, and used. These are what we called the stages of representation or the stages of cognitive development, which are enactive, iconic, and symbolic. Now, let us understand them one by one. The enactive stage, which is 0 to 1 years. The enactive stage is the first stage of cognitive development. During this period, learning occurs through direct manipulation and interaction with objects. Infants learn about the world around them through their actions, touching, holding, and moving things. For example, when a baby shakes a rattle and hears it makes a sound, they learn that their action, which is shaking, has a consequence, the sound. This stage is all about doing. To apply this in education, think about hands-on learning in early childhood settings. A preschool teacher might set up stations where children can play with different textures, build with blocks, or engage with sensory bins. This activity will help children develop foundational cognitive skills by physically interacting with their environment. Educators working with infants and toddlers often focus on activities that encourage exploration and direct engagement with the world. For example, activities like playing with clay or even peekaboo games help build cognitive pathways that lay the groundwork for more abstract thought later on. Now, coming to the iconic stage, which is 1 to 6 years. In the iconic stage, children start to use visual images and symbols to represent objects and events. Here, learning shifts from physical actions to mental images. This stage is characterized by the use of pictures, or icons to stand for objects, people, or experiences. For example, a child might draw a picture to represent their family or use a map to find their way to school. They begin to solve problems by thinking about them rather than physically manipulating objects. An example of this could be a child imagining a picture of an apple when asked to think about fruits. In the classroom, this could be supported through the use of visual aids like picture books, charts, and diagrams. For example, a teacher might use picture cards to help children associate words with images, such as showing a picture of a cat when saying the word cat. These methods help children make connections between the visual representation and the actual object or concept, which is foundational for later learning. Now, coming to the symbolic stage, which is 7 years and above. The symbolic stage is the most advanced stage where children use abstract symbols such as language, numbers, and other symbol systems to represent and reason about the world. This is where more complex cognitive activities take place, including advanced problem solving, logical reasoning, and abstract thinking. For example, in mathematics, a child learns to use letters and symbols to solve algebraic equations, such as understanding that x plus 3 is equal to 5 means that x equals 2. They are not seeing a literal object or picture of x, but understanding that it is a symbol representing an unknown value. In the classroom, teachers can apply this stage by introducing concepts that require abstract reasoning, like scientific theories, philosophical debates, or mathematical formulas. The idea here is to encourage students to go beyond concrete experiences and use higher order thinking skills to analyze, synthesize, and evaluate information. For example, in a literature class, students might be asked to interpret a poem's symbolism rather than just summarize its content. Please keep in mind that, unlike Piaget's stages, Bruner's stages are not strictly age restricted. The age brackets provided are only indicative to help educators understand the typical developmental sequence. They are flexible and can vary based on individual learning experiences and context. Now that we have understood the theory, let us move on to the educational implications. This theory promotes constructivist learning. Bruner's theory focuses on active learning, where students build new knowledge on what they already know. This encourages exploration and discovery rather than passive learning. For example, instead of just explaining the water cycle, teachers can let students conduct experiments to explore evaporation, condensation, and precipitation. Next, this theory supports differentiated instruction through scaffolding. Scaffolding provides temporary supports tailored to students' learning stages. As students gain confidence, these supports are gradually removed. For example, in teaching essay writing, teachers can start with guided prompts and slowly encourage independent writing, helping students become self-reliant. Next, this theory also encourages deep learning with the spiral curriculum. The spiral curriculum revisits core concepts at increasing level of complexity, reinforcing understanding over time. For example, students might learn about ancient civilization in elementary school and revisit these concepts in more detail in higher grades, developing a deeper comprehension of historical context. Next, this theory also facilitates meaningful engagement and motivation. By emphasizing discovery learning and problem solving, Bruner's theory fosters meaningful engagement. When students are actively involved, their motivation increases. For example, project-based learning allows students to work on real-world problems, enhancing their interest and participation. Next, the Bruner's theory enhances cognitive development through representational stages. Aligning teaching with Bruner's stages, enactive, iconic, and symbolic, ensures developmental appropriateness. Young students benefit from hands-on activity, while older students engage better with visual aids and abstract reasoning, supporting effective learning at different cognitive stages. Next, this theory prepares students for advanced learning and critical thinking. Progressing through Bruner's stages and incorporating scaffolding and spiral learning helps students develop critical thinking and problem-solving skills. For example, activities like debates teaches students to use language and logic, preparing them for advanced academic and professional challenges. So that was all on today's class on Bruner's theory. I hope you liked the video. Please let me know in the comment section. Like, subscribe and share. Thank you for watching and see you in the next class.